How's it going, guys? Damien here. So today we're going to be talking about resistors and how we use it within the breadboard circuit. So what is a resistor? A resistor basically limits or controls the amount of current flow we have within our circuit. Alright, now we're going to get into the why. So like I just mentioned, number one, it's to limit or control the amount of current we have within our electrical system or circuit. Number two, we would use it for voltage dividing or voltage drop. So let's just say I would have different electrical components within my circuit that require different amount of voltage. We would use resistors with a properly rated resistor to get a desired voltage drop to that component. So lastly, something we don't really talk about is heat dissipation. So let's just say I have a circuit built on my breadboard and I'm using capacitors, inductors, and I have now maybe an excess amount of capacitance or an excess amount of inductance, so that would leave an excess amount of heat on my electrical system or circuit. So how do we store that heat? We can safely store that heat using a resistor. So that's another major reason why we would use resistors would be to store excess heat of our electrical system. All right, now most important on how does a resistor actually work. So we know that a resistor works using Ohm's law. So obviously your E equals I times R. So in theory, if you have a bigger resistor, you would have a bigger voltage. If you would have a smaller resistor, you would have a smaller voltage. So that's basically how we use it. And next I'll get into how we actually wire it up using a breadboard. Alright, so before I show you guys how to wire this up, I'll give you guys a rough idea because I will be showing you this in class on the breadboard. I want to go over the different types of resistors. So number one, you have your wire round resistor. Number two, you have your metal film. Number three, you have your carbon film resistor. Alright, now that we got that out of the way, I want to go over how you actually identify the amount of ohms there is in your resistors so that we know what resistors to use for the required voltage drop. So first, you're going to have a 5-band resistor, or secondly, you're going to have a 4-band resistor. So depending which one, you're going to have different colors on the actual resistor. I will be showing you guys this in class so you guys can have you can have a better idea of what it is. But let's just say I would have brown, black, and red. That would indicate that I have a 1,000 ohm resistor. We know this based off the, the standard resistor color band chart. So let's say I have a 1,000 ohm resistor, I wire it up. I calculate for that voltage drop to my desired light. So I would have, my power come in here. I would use my resistor for the two leads over here. Let's say I would have my electrical components. It would be an LED light that requires a certain amount of voltage, or maybe I don't need 1,000 ohm. Maybe I need less. So yeah, I would also have my electrical component with the resistor before the component. Then I would complete my circuit back to the neutral. That's basically how it is.
Today I'm going to be going over the different kind of circuits you can have on a breadboard. I'm going to be going over series circuit and parallel circuit. To start off, series circuit is when a component is wired one after the other. As you can see on the image, it's a light wired one after the other. A series circuit is when the current flow is in a singular path and the current is the flow of electrons. So in a series circuit, they're going to share the voltage, so the voltage is not going to be the same throughout the two light bulbs, but they're going to have the same amount of current. So that means that whichever light has the higher amount of resistance is going to have the higher amount of voltage. In a parallel circuit, it's when there's two paths for the current flow. So on the image you can see that the wire splits going to two different lights. So that means the voltage is going to be the same, but the current is going to split off at that point.
Hello everybody. Today I'm going to be talking about lighting and electronics. So lights actually have a lot of usage in electronics. They can serve as visual indicators, sources of illumination, communication, just plenty of other things. So every day, you use lights a lot more than you think, like the light in my room, my phone actually, the resolution of my phone is 1920 by 1080, or let's say the resolution of my monitor more or less is 1920 by 1080. I have it right here. So that means that there's over 2,073,600 pixels, and one pixel is essentially it's a light. So another example of lights are the lights on my super yacht, the lights on my super car, the lights on the brand new mansion I bought my mother. plenty of other examples for lighting. Examples for visual indications are traffic intersections. You know, you use those every day. You know, when it's red, you stop. When it's green, you go, right? That's your visual indicator right there. And a daily thing you use as a source of illumination are city lights or your car lights. So, you know, city lights are all programmed through PLCs, and PLCs essentially are all electronics related. And in communication, visible light is used by modulating its brightness, like lights like LEDs, to transmit data wirelessly. So in electronics, they're used to indicate and transmit, provide visual output. So let's say, I don't know, on my phone, I get a 20% battery life indicator. Well, those are all lights, right? There's also when your fuse trips, there's some fuse that in your PLC cabinets, when the fuse is tripped or the fuse is blown, there's a red indicator light that will pop on. For example, today we're going to be showing the effect of a light in a series and parallel circuit and a light under resistance. So from what we've learned today, Mrs. Partridge will have to figure out what's going to happen to the light.
Hello everyone, my name is Matt, and today I'll be teaching you guys about breadboards, so let's dive into it. What they are. Breadboards are small, light, plastic rectangular boards that are used to power up circuits, which we'll be showing you guys a demonstration of shortly. In order to build a circuit, you would actually bring your 5-volt supply into the terminal strips and then into the main grid. Now I'll be diving in on the more visual and practical side of the board. As you can see, we have 2 terminal strips on either side of the board. In this case, we have the left side and we have the right side. These strips have 2 lines, one red, one blue. The red line is the positive and the blue line is the negative. These terminal strips are the terminal power grids for the main power grids in which you'd build the circuit. Inside of the power grid, there are small metal clips which intertwine each row so that they're connected together when powering the actual circuit. Now, to give a small example, I'll wire up a quick short circuit. So, we could bring a wire into here, and let's use a fuse as a device for an example. We could go like this, like that. So now we have a power wire going into the main grid attached to a fuse. Now, let's say we want to go onto the other side. We could use another wire, bring it onto the other side, and add a light. Now we have our main power wire that goes into a fuse and skips over to this side onto a light. Now all we have to do is ground it. That is the basic principle of a breadboard.